This is a video to do more examples with trig integrals. So think of it as a continuation of 8.3. I'm getting all of these examples from your book, page 540. So if you wanted to look at these in your book while I'm doing them, that's fine. Okay, so this is number 6, and it says we have to evaluate the integral of cosine cubed x times sine to the 4th x dx. All right, so remember with sine and cosine, we are looking for odd powers. That is cosine here, so we're going to reserve a cosine for our du. And then that leaves me with cosine squared x and then a sine to the 4th x. Remember, we're going to take the rest of those cosines and convert them into 1 minus sine squared. So convert them into sines. Okay, so distributing, I have the integral of sine to the 4th x cosine x dx minus the integral of sine to the 6th power x cosine x dx. All right, let's integrate. My u is going to be sine x. My du is going to be cosine x dx. I put an extra dx in there. All right, getting dx crazy. So this is just sine x. This is cosine x dx. All right. So this is going to be the integral of u to the 4th du minus the integral of u to the 6th du. So this is 1/5 sine x to the 5th minus 1/7 sine x to the 7th plus c. And you can write the 5th and the 7th right by the sign if you'd like. All right, so there's an example, a beefier example of taking out a single cosine or a sine. We did not get to do one with an even power, so let's do one like that. So number 16 has us integrating the sine to the 4th of 2 theta d theta. So remember, we're going to use the fact that sine squared of x is equal to 1 minus cosine of 2x all over 2. Okay, so remember our x, right, from this formula is representing 2 theta. So we're going to be doubling a 2 theta when we use that integral or that formula. So when I rewrite this integral, I'm going to be doing 1 minus cosine of 4 theta over 2. Okay, and I got the 4 theta because I'm doing 2 times that green stuff. Okay, so, and then all of that is just sine squared, so I would have to square that. Okay, so if we square that, that's going to give me a 1/4 out in front. And then I'm going to distribute, so that's going to be 1 minus 2 cosine of 4 theta plus cosine squared of 4 theta d theta. Alrighty, so let's see what we've got here. We've got, for this first part, we've got 1/4. This will just be theta, right? 1/4 theta. This one's fine, it's just the cosine. So just keep in mind that this is a 4 theta, so we really need, let me rewrite this with a different. I just want to be clear about what I'm saying here. And then we've got, so we've got 3 integrals, is what I'm pointing out here. And they all have 1/4 in front of them. Okay, so now I'm ready to talk about the 1/4 theta. Here, this is going to be my u, so my d would be 4, so I'd want to compensate for that right there. All right, so I'm going to have a half times a fourth, so that'll be an eighth, and that'll be sine of 4 theta. And then I have a fourth in front of here. This is, remember, I can't do this without a sign in there, so I have to do another formula here. Okay, so remember that the cosine squared one is going to be a plus instead of a minus. So I'm going to replace all of this stuff with 1 plus cosine of 2x. So that's 2 times 4 theta all over 2. So that gives me 1/4, well, 1/8, let's say it's 1/8, 1/8 d theta plus, then I'm going to have a 1/8 cosine of 8 theta. And then again, I would need, when I integrate this one, I get just theta. And then over here, I need an 8 in front of here, so we compensate with another 1/8. So that's going to be a 1/64th sine of 8 theta plus c. All of this other stuff gets brought down, so I have 1/4 theta minus 1/8 sine of 4 theta plus the rest of that. All right, so yeah. You could combine the thetas, I guess, if you wanted to, but keep in mind you can't combine these signs because this is 4 theta, this is 8 theta. So we could combine the 1/4 plus the 1/8, so that would be 3/8. But that's about all you can do to simplify that. So there you go. There's one that has both using the sine squared and the cosine squared. So that one's a good one to have under our belts. All right, there's also something in your homework that is using Wallace's formula. This is on, the Wallace's formula is on page 536. However, the problem is still on that same page, and it's number 20. Okay, so Wallace's formula is a quick shortcut for doing definite integrals with these trig these trig integrals techniques. Okay, so Wallace says that if I have cosine raised to an odd power, then I'm going to, this integral is going to be equal to, he says if this is cosine to the 5th power, then it's going to be equal to doing these fractions. So it'll be the same thing as doing 2/3, then the next fraction would be 4/5 times 6/7, and so on, all the way up to n minus 1 over n, and n is simply your power. Okay, so here on this one, our power is 5. So we're basically just going to stop here in that formula. So this is saying it's just equal to 2/3 times 4/5, which is pretty easy to do. That's just 8/15. So yeah, it's a shortcut, so you don't have to do any calculus. So it's kind of nice if you have the specific integral from 0 to pi over 2 of cosine, but it's a very specific one, so we don't see it that often. You won't see it on the AP, but just so you know that it's there, and if you have any homework questions on that, you'll be ready for that. We also didn't get to do in the guided notes any more of the tangent ones, so I wanted to show you a few more of that. There was the one rule that was dealing with even power of tangents, so like number 30. So it says just take out an even power, convert it to secant squared, and then take the rest of the tangents to be tangents. So here I've only got one or tangent squared, 1 tangent squared, there's nothing left over is what I mean. So we're just going to convert this to be secant squared x minus 1 dx. So this is going to be simply, what's the derivative of secant squared? Well, that's just tangent, right? Okay, so this is going to be tangent of x. This is just going to be minus x and then plus c. So that one's pretty easy. But if you had more tangents, you would just convert them or keep them as tangents and then use that as your u, and then secant squared would be your du. All right, and then our last example that I'll do is number 40. And this is dealing with an odd tangent. Now notice that there was nothing in the guidelines about a tangent raised to an odd power. So we are going to use that last strategy that says change everything into sines and cosines. All right, so let's do that. All right, so what we're going to do is use our sine and cosine rules, and since sine is the only one that's positive, remember it did say that the powers have to be positive, the cosine is negative since it's in the denominator. So we're going to use the odd power rule for the sine. So I'm going to hold out a sine, which leaves me with a sine squared in the numerator. I still have the cosine cubed in the denominator, but what I have out here is the sine of 3x dx. That's like my du. That's going to represent my du. Okay, so I'm going to change my sine squared into a 1 minus cosine squared. And all of that is going to be over cosine cubed. I still have my du part. All right, and now we're just going to simplify these. That first integral is going to be my du over my cosine cubed. So I'm going to have sine of 3x dx over cosine to the third power of 3x. And then I'm going to have minus. I'm going to have cosine squared over cosine cubed. So that's just going to leave me with a single cosine in the denominator. So cosine of 3x. And then I still have that sine of 3x dx. Okay, so we're ready for the u substitution. Our u is cosine of 3x. So our du is negative 3 sine of 3x dx. So all of these need a negative 3 and a compensation with a negative 1/3 in the front. Okay, so I'm going to rewrite these with u's. So this is negative 1/3 integral of u to the negative third power du. And then this one, since I have two negatives, I'm going to have a positive 1/3 u, or du over u. Okay, let's integrate. So I'm going to add a power to that u to the negative 1/3, and that's going to be 1/2, or no, I'm sorry, u to the negative second, and then I'm going to divide by a negative 1/2. I keep saying that wrong. I'm going to multiply by a negative 1/2, divide by the negative 2. There we go. And then I'm going to have the 1/3 ln of u plus c. So now let's fill in those u's. So I'm going to have positive 1/6 cosine. I'm going to put the cosine in the denominator. So this is cosine squared of 3x. And then here I'm going to have 1/3 ln of cosine 3x plus c. Now the only thing I would do here, just so it looks more like what you would see in a calculator, we would probably change that to be secant squared. We typically don't leave it those powers in the denominator, so This would be secant squared 3x plus 1/3 ln. Alrighty, so there are some extra examples for you, so if you wanted to see how those different rules work.